sensory information from the body about the body's position and communicates it back to the brain, all of which is critical in maintaining a predator's gaze on its prey.
So birds have a large flocculus, which makes sense. The question is, why did pterosaurs have such a large flocculus? And so it got me thinking, what is different about birds than pterosaurs?
Birds' wings are made of feathers, which don't have nerve endings in them. But well-preserved pterosaur fossils reveal a wing that is made out of a thin membrane of skin.
A skin that's richly supplied with nerve endings. And so what that suggested to me is that potentially the pterosaurs were receiving a huge amount of sensory information from that wing, communicating up through the spinal cord into that gigantic floccular lobe of the cerebellum for processing.
So, pterosaurs' wings had more than just an aerodynamic function.
In pterosaurs, what they've done is they've also turned their wing into essentially a smart wing, a gigantic sensory organ collecting all kinds of information, potentially on things like airspeed, angle of attack, all of these kinds of things that would then be communicated back to the brain.
This would then be coordinated with information on balance coming from the inner ear, and then relayed to the eye muscles to keep the gaze fixed on a target.
A lot of effort to keep your eyes fixed on a target, but if you're a predatory animal, that's the difference between a meal and potentially no meal. Pterosaurs were indeed, in a sense, more highly attuned and sophisticated aerial predators than what we had thought before.
It's almost like a sort of autopilot device. In other words, if there is a turbulence in the air, wing would be able to pick it up and send information to the ear, and ear will tell how to adjust.
Our efforts to understand these creatures can take us on a journey inside